Okay, so now I'm going to go over the first two questions on the worksheet, as these are about sampling. So after I read each question, I'll just pause for a second in case you want to pause this video and think about the answer. So number one is, what is the connection between applying a box blur to an image and super sampling each pixel within the image? So in fact, applying a 1 pixel box blur is equivalent to super sampling on each pixel. So say you have some box blur that is of size x by x. What you're doing here when you apply it to an image is you take these x by x samples of some area of your image. So say this is your area of your image. You take x times x samples, you add them all together, and then you divide them, which is essentially averaging all the values in this area. So, and then if you think about super sampling, you're actually doing the same thing. So say you have some sort of image and you take x by x samples in this area. All you do there is just average them up. So in fact, if these dimensions here of your box blur and the amount of super sampling you're doing on each pixel are the same, then you're doing the exact same thing. So now let's move on to number two. So let's say we have two wheels that rotate at different speeds with different numbers of spokes that we want to record with our camera. Let's say wheel A has 4 spokes and rotates 6 per second, and wheel B has 6 spokes and rotates 5 times per second. What is the lowest integer frame rate in frames per second we need on our camera to avoid any aliasing effects? So, when we think about our wheel rotating, any time that it's in this position, it'll look exactly the same. So, if we look at this 4-spoke wheel, every time it rotates 90 degrees, it'll look exactly the same. So that means if we have our wheel rotate 6 times per second and it looks the same 4 times in one rotation, then we'll have a frequency of 24. And then we can do the same math for the wheel B. So as you can see, there's 6 spokes, which means it will look exactly the same 6 times within one rotation. And if it rotates 5 times per second, that means that its frequency will be 30. So now we know from the Nyquist theorem that we need to sample more than double the highest signal frequency. So since we know the highest signal frequency is 30, then we're going to need to sample greater than 60 times per second. So the lowest possible frame rate that we can sample at to avoid any aliasing will be 61 frames per second.